Good afternoon, good morning, good evening, everybody. Thank you for joining our Kubernetes masterclass today. It's Tuesday, September 22nd. I will go over a few housekeeping items and then we can jump into our topic today, which is service meshes and API gateways. So quick intro, myself, if you've attended our Kubernetes masterclasses before, I'm Connie Lin, the manager of global events here at Rancher. And today's speaker will be Jason, one of our field engineers who has done a couple previous masterclasses. So, Jason, you there? You want to say hello?
Welcome, everybody. I hope this will be informative and useful.
So just a reminder, the class usually takes between 45 to 75 minutes. We will do our best to answer any questions that you have. So if you do have a question, you can pop it into the questions tab on your GoToWebinar panel, and we'll respond either via chat or kind of go through them throughout the session. If you have not yet, go ahead to slack.rancher.io to join the Rancher user Slack channel. We do have a Kubernetes masterclass channel dedicated to all of our classes there. So head over there to chat with everybody else who is attending today. So with that, I will hand it over to Jason to take us into the class today.
Cool, thank you. So I'll go through a little bit more introduction of myself, explain the context of this masterclass. And then, unlike some of the other masterclasses that I've done in the past, where it's basically me just reading through a slide deck and showing you a pre-canned demo, I have a couple environments stood up, and I don't know exactly how this is going to go, but I'll be able to field a couple questions, maybe talk about the specific technologies that are in play there and the difficulties that I went through, but leave it really flexible so that I could answer. Go down specific rabbit holes as you want me to go down. We only have, I think this is scheduled for an hour. Is that right, Connie?
Yeah, just about 1 hour.
Cool. So I have 4 main sections. So I'll probably designate about 15 or probably about 10 minutes to each and give a little bit of a break in between for questions and answers. So if it seems like I'm in the middle of a specific topic, maybe wait a little bit. There'll be a divider where you'll know that you have the opportunity to ask questions, because there are a fair bit of you. There's over 100 that I can see, and I can only answer so many questions at once. But without further ado, you're all here because you at least know the words API gateways and service mesh. Hopefully you're running some form of Kubernetes cluster. Maybe you have some microservices in your organization. We'll explain the context of that in a little bit, but this is going to be the synopsis, the sections that I talked about. First we'll talk about background, then we'll talk about specifically the service mesh that I'm going to use today, why I made that decision to use that service mesh. I'll take you through CVE that was recently reported, and then I'll go through 3 different gateways. Every time you'll see them, they'll be stored, they'll be alphabetically sorted. I try not to show preference to to either one of them. They're all great open source solutions. They're all based on Envoy. They all have their own specific implementations. But as far as TLDR, if you guys wanted to log off right now, get everything that you're going to get out of this meeting, you should probably use both API gateways and service mesh, because as the community has established over the last couple of years, they both have their pros and cons. There are overlaps, but some of them are more accessible from one technology stack as opposed to another. So moving on. This class may be helpful if you are already running either an API gateway or a service mesh, you are using Kubernetes to manage your API resources, and you would like to deploy any of the following strategies in your microservice architecture, be that MTLS, telemetry, rate limiting, traffic shaping, distributed tracing, request transformation, circuit breaking, so on and so forth. Reasons that you might want to check somewhere else. For background on this presentation, you are not familiar with Kubernetes resources, I'll be going in and out of various kubectl terminals. I'll be going through Rancher's product to show services, ingress, and deployments. So if you're not familiar with that, and I do context switching a little bit too fast, obviously, if I am going too fast, please leave a comment. I'll try to slow down. But some base level familiarity is more or less required for this course. Similarly, but less strictly, if you are not familiar with Istio resources, there might be a couple things that you have to go and look up after this presentation is done, maybe on your second watch, if you find it useful. The main components that I'm going to be using from Istio are going to be gateways, virtual services, and destination rules. As a primer for that, a gateway is going to be how you're going to get traffic into your service mesh. Virtual services are going to be how traffic is routed throughout your service mesh. And the destination rules will be the policies that are applied more or less at the endpoints of those services. Two other points that are soft requirements for getting value out of this masterclass are going to be some familiarity with Helm, or at least a way to inject Kubernetes deployments and resources into a cluster. I started this presentation with the assumption that I would just be using Helm for all of the components. You'll see as I go through the presentation that ended up not being the case. So that's less strict as it was when I wrote this. And then lastly, you cannot differentiate authentication from authorization. I don't have too many specific demos where maybe I'm leveraging OIDC or specific user authentication or authorization, but it's important to know that they're two different things. Authentication is showing who you are, authorization is showing what you can do. So I think the title of the synopsis of this presentation was built around the fact that, there's actually a presentation here I can show. Let's view animations, preview. That's not gonna do it very good. But if I bring this to the front, you can see that each of the gateways that I've talked about today has discussed this topic. This topic has been basically around since Istio came into the foray as a solution for microservices and getting consistent approaches to how you're handling routing, shifting, so on and so forth. You can see from Ambassador here, they do an API gateway versus service mesh. I think this is actually a C-level employee from Ambassador. I don't remember. Sorry if I can't switch to presentation mode. I just got a question. Let's see. Let's try showing a different screen. Let's show that. How is that? Can you see the truth is out there and only the truth? There you go.
Yeah, we see the truth is out there slide.
Cool. So the animations, I went through them one by one. Going back to Ambassador, the idea here is that Ambassador, I think, was one of the earlier ones. I don't think it was the earliest of them, but it's going to be an API gateway that has more or less your developers at heart, with the ability to do a portal with interacting with your API services. And as Istio and Linkerd and Console, all of them started to grow in popularity, users needed to know where the boundary is between an API gateway and a service mesh, maybe what the migration strategy should be to go from one to the other, or just how to get the most immediate value from both of them. Similarly, I brought that to the front now. 1 second. Let's push that back and then go back in presentation mode. The second article that I mentioned was from solo.io. Solo.io, this is actually a presentation on YouTube that Christian posted, I think a couple weeks ago, if not a month ago at this point, where he talks about the difference between API and service mesh. And then lastly, the folks at Kong HQ have done the same thing. You'll notice that the two from Solo.io and Kong are pretty recent. September 10th being when I guess that's only a week ago at this point, 2 weeks ago, being the most current one, but going back to February earlier this year and then to September 2 years ago. So this has been a question that's been floating around, and apparently it's still something that people get tripped up on. So with that in mind, let's try and make this as simple as possible. And I'm borrowing a little bit from how does this question that I just got from the channel, how does this relate to an enterprise service bus? An enterprise service bus is similar in ways to an API gateway. You could implement an enterprise service bus with an API gateway. I don't exactly know what I guess the legal definition of an enterprise service bus is, but without that, let's assume that an API gateway is closer to an enterprise service bus than a service mesh would be. Basically, you just want a single location to interact with all of your services for your organization, maybe give you the ability to route things between services, maybe to, basically an enterprise service bus is going to give you service discovery. Let's stop there before I ramble on. As far as the difference between an API gateway and a service mesh, and you'll notice that there's a dotted line here because, like I said, there's a lot of overlap. The main functionality of an API gateway is, I have in quotes there, to take less. The idea being that you're trying to abstract away all of the infrastructure, all of the complexity of your microservices distribution, and provide a quick and easy way to get more advanced use cases from those APIs. Some of those examples being traffic rate control, throttling and quotas, being able to say that after a certain point of time, if somebody's spamming this API, you'll throttle them down based on maybe headers or JWTs that are associated with them. Giving a specific user the only X amount of requests within an hour to a specific API is a good way to handle to safeguard yourself from basically distribute DDoS attacks. Sorry, I stumbled there for a little bit. Then there's request transformation. Request transformation is definitely something that has an overlap, but request transformation is something that API gateways have been doing more or less since the beginning. And so it makes sense that they've got the history. They would continue to do that in a pretty quick and easy way. And that's modifying headers, request body, and the query parameters of a specific request. So if you're familiar with REST APIs, if you're going to / question and you wanted to see the first element of question, you could go from questions and default to redirect more or less to the first question or the last question. And then lastly, caching. Last but not least, caching. Caching is going to give you flexibility, or is going to give you much greater performance. For instance, if you have, let's say you have a request that is in a service mesh in your Kubernetes cluster, and you have many microservices, you have one request that will bounce all the way around through 4 or 5 microservices and then finally back out of the cluster. Caching will gives you the ability to eliminate some of the requests so that they don't even need to go into the cluster, saving you resources and saving you time. On the other side of things, we have the service mesh. The service mesh, I have in quotes, give more. And what I mean by that is that the service mesh is going to give you a consistent view of your entire microservices architecture. So things are going to bubble up from it. One of those give more aspects is going to be MTLS. MTLS, for those of you who don't know, is going to be encrypted communication back and forth where both sides of the API request are going to be validated to be basically the identity of each will be guaranteed based on the certificates that they provide. Istio does a great job of handling that automatic these days. And so it's basically, you get that functionality from Istio install with maybe 1 or 2 flags. 2 of the other components that are in this give more category are telemetry and observability. Telemetry and observability are going to come out of the fact that you're doing everything in a sidecar model, that everything is going to be applied unless you specifically configure at your environment such that certain workloads are outside of the standard framework. You're going to get Zipkin or tracing. You're going to get some Prometheus components because that's just the standard that's applied to every sidecar proxy and the traffic that goes through it. So you don't have to worry about, in the API gateway case, of adding individual services. And then lastly, one of the benefits of a service mesh is the resilience. The service mesh most often being deployed on top of Kubernetes, you'll get all of the benefits of the resilience of Kubernetes, as well as being able to do more advanced circuit breaking, traffic routing, traffic mirroring, so on and so forth. So without further ado then, that brings us to the substrate of this entire talk. I've chosen Istio as my service mesh. I've chosen Istio as my service mesh because for those that you may be running Rancher, may be leveraging Rancher in their own work, their own organizations, know that we have a direct Istio integration. That Istio integration is, I can show you in a couple of seconds, is pretty straightforward. That's going to be based similarly to the way we do all of the other integrations. They're going to just be Helm charts, which may or may not change in the future as Istio continues to evolve. But before I go on, I want to mention something that came up a couple of weeks ago. I'm gonna put the date in here. I think it was, well, let's just say a couple of weeks ago. But there was a CVE that was identified with Kubernetes. I got this information from a Sysdig article. The Sysdig article reported that CVE 2020-14386 is a result of a bug found in the packet socket, blah, 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 blah. The main idea here being that this vulnerability is using the functionality of CapNet raw in your cluster so that it can get root access to the node. I have a question here, let me read that. Wouldn't any enterprise implementation require both the API gateway and the service mesh? I wouldn't say that it requires it, I would suggest it. You're going to get the ability to get a quick and easy MTLS with a service mesh perhaps, and then for API gateway, you're going to start to be able to expose or have an interface for your users in the APIs. But I wouldn't say it's a hard requirement. Going back to the CVE, the reason I brought up Sysdig is because their document suggests, and wisely so, that you want to secure against this by creating a pod security policy that disables CapNet raw on your clusters. But do you know what uses CapNet raw? Istio does. When Istio first boots up a sidecar, well, a workload that's in a namespace that has Istio audio injection set up, the Istio init container is going to try and change some of the networking rules. It's going to leverage CapNet raw to do so. And so if you were to enable a pod security policy in your cluster to disable CapNet raw, you would effectively, unless you've gone through the moderation that you follow, the remediation steps down below, you'll be turning off your Istio capability so that the containers just can't run and you can't communicate with your services. But long story short, if your security team is looking to address it and remain functional, so if you're running Istio at present and your security team is really itching to mitigate this CVE, you could do so with a CNI plugin. Istio CNI, Istio Container Networking Interface. First of all, what is it? The CNI replaces the need for the Istio init container to modify network configuration of a pod, whereas the Istio init is an init container in a pod. It will make changes to IP tables. It will require those CapNet permissions. The CNI is going to do so with the network lifecycle phase of the pod. So it's outside of the permissions of the pod itself. It's in the Kubernetes level. It's in the control plane effective level of of creation, so you don't have to worry about adding this extra permissions. How do I get it? There are two main ways that you can get it. You can install it with a Helm chart. You can following the same practice that most Helm charts are installed with, Helm repo add and then Helm install, or you could install it with the Istio operator. I'll point to the documentation here in a little bit, possibly, but the two steps here being that you're dumping out an Istio cni.yaml file with the configuration, and then you're just doing istioctl install f istio cni.yaml. I do want to mention here that the istioctl install command, that's working on a more current version of Istio. If you're going backwards and maybe running Istio 1314, I don't think that flag, I think it's Istio manifest apply at that point. Just to be aware that Istio has made some changes to the way that their CLI tool works. And then what configurations do you have available to you when you've set up the CNI? First and foremost, probably the most important one is the exclude namespaces functionality. Excluding namespaces, you probably just want to exclude Istio system. You might have requirements that you're excluding other namespaces. Basically, what that's going to do is just going to make sure that the namespaces that you're excluding don't go through this network lifecycle phase where they're adding their routes to the service mesh. Log level, as always, if you want full introspection, if something starts to break, you can always log level debug, log level warn, log level debug. PSP cluster role being the cluster role that is acting on behalf of. And then the last two options, which to me were new options, are the repair.enabled and the repair.delete pods. What this does is Istio will try and remediate pods that for some reason or another can't spin up, can't join the service mesh. And those two options, you could do it in an automated fashion or you could do it manually. It's newer because I think a lot of people in the past either weren't using the CNI or they just wanted to do it manually. I haven't tested the repair.enabled functionality. That's something that I plan to do at some point in time, especially now that that CVE was released. I'm probably going to switch over my clusters to all running the CNI. When I switch over to the Rancher console, if there's interest in running showing either of those installation steps for the CNI, I could certainly go over that. But moving on. So what can we expect from an API gateway in 2020? Assuming that we're using both the service mesh and an API gateway, and assuming that we've standardized, in this case, it's just me that's standardized on the service mesh being Istio. We'll take the service mesh expectations off the table for now. What can we expect from an API gateway? First and foremost, it should be straightforward to use and install. At this point, I have pretty high standards for anything that interacts with a Kubernetes cluster. Helm charts, love them or hate them, give you the ability. Okay, cool. It does look like we have a request to go over the Istio CNI install. I will do that. Helm, customized, there's lots of ways to get things into a Kubernetes cluster, assuming that you have the documentation for either of them is parsable by your SREs or your Kubernetes team. It should be pretty straightforward to deploy some form of application. And then secondly, you want it to follow common practices within the Kubernetes ecosystem, either using annotations, CRDs, controllers, or ingress. Secondly, which I won't go into, we'll go into a little bit of detail, time permitting, is performance. One thing that I've kind of standardized across is Envoy. There are other service meshes, and there are other API gateways that don't leverage Envoy. But the key thing here is that even with the standard across Envoy, there could be some architectural and implementation details that add additional latency. And so we'll tease those out a little bit here. But for the most part, you don't want the combination of a gateway and a service mesh adding minutes upon, or adding seconds or minutes to your API requests. That is something that I don't actually have listed in this slide anywhere, or in this presentation anywhere, is that would be the negative or the counterpoint to running both of them, is that will add a fair bit of hops. But as I mentioned earlier, caching will help eliminate some of those latency issues. The last thing about what we can expect from an API gateway in 2020 is integration with a service mesh. Because we are getting to the point where it's getting more and more understood that API gateways and service mesh can still live alongside each other harmoniously. You want the ability for them to communicate over MTLS. So if the API gateway, you can effectively think of the API gateway being the hard candy shell over your service mesh. And so you don't want mutual TLS to start with just the gooey chocolate center. You want it to go from the hard shell all the way down to the core. If possible, you'd want that also to extend to the tracing components, maybe the metrics, the observability components, so that you get full visibility of your routes, regardless of what components they're passing through. And then lastly, this is something that's one of the main selling points of Rancher as an orchestrator is that you can consolidate all of your management through one consistent pane of glass. And I think that policy or that practice should extend to service mesh and API gateway. And if it's not a general hard and fast rule, me as a developer, me as a user, I just don't like switching screens very often. So that's just my own personal opinion. That brings us to the Ambassador Gateway. But since we did have a request to go over the install of the Istio CNI, I will take a step out here. It shouldn't take very long to go over the basic practice, and then we'll hop right back into the gateways. So I think you guys are still seeing my right screen, which you should see a Rancher window now. Could somebody confirm in the questions, or Connie?
Yeah, I see the Rancher
Cool.
window. Could you enlarge it just a little bit
Yep.
so we could see it a little better? Great, perfect, thanks.
Cool. So I did mention that there are multiple ways to install a Kubernetes cluster, or to install the CNI. One of them being through the Helm chart. I'm going to go over that now. Istio CNI Helm chart. I think they transitioned over in the 1.7 universe to using strictly the operator, but they still do provide the CNI in Helm form. And because of the way that the ease of use with Rancher, I would suggest that you go through with that, or give that a try before you switch over to running maybe Istio through our Rancher integration, and then running the Istio operator through for the CNI, just to kind of consolidate the operability there. The fields that I mentioned previously, the log level, the exclude namespaces, you can see the default is Istio system. There are a couple of bin directories. I didn't think that those were necessarily too relevant. There's the pod security policy cluster role. The description there tells you enough. And then there's the repair functionality. Enable or disable the CNI race condition detection and repair functionality. This injects an Istio validation init container into every injected pod and which checks if the Istio CNI correctly initialized the pod's networking configuration. It also enables a new container in the daemon set which monitors for pods or either labels and deletes them per the values below, so on and so forth. But I want to go into let's go into 1.5, go into docs, we'll go into setup, we'll go into installing Istio with the CNI plugin. Here we can see the Helm chart parameters. They're going to be I guess that one has been around for a while. Let's see if I can find the chart repo. Istio chart repo. Here we go. So we're going to add this as the chart to Rancher, Tools, Catalogs, Add Catalog, Catalog URL. We're going to use Helm 3. Let's call this Istio. Create. We should see this show up. Helm 3. Now if we go into Apps, if we click Launch, we should see Istio, Istio CNI, and Istio init. We click on Istio CNI. In the detailed descriptions, I guess there aren't very detailed descriptions, we could go through and deploy this to a new cluster. I have one cluster that I can deploy this on top of. Let's deploy this on, let's not deploy this on the local cluster. Let's just deploy this on the Snowdriver cluster. You click into the default space, click on Apps, click Launch, Istio CNI. Double check that we have default there. Repair enable is set to true. Okay, okay. We're going to use the 1.5.4 CNI, and then we're just going to click Launch. It's going to go through and create the CNI as a node agent, or as a daemon set. And let's see if there's anything meaningful. Change CNI plugin. So if you wanted to join this with another CNI, you certainly could. It's got the repair node functionality. But that's more or less how you would deploy the CNI. Details of the Helm chart, how we can deploy using it. We go into the details of the Helm chart. How can we deploy using it? So once you've installed I guess the one thing that I'll answer or kind of wrap up the CNI discussion is that the CNI components will replace the init container. Once you've done that, the documentation should make a reference to the fact that you install the CNI, you verify that, and then you get rid of the init components so that you don't have the duality there. Yeah. Let's double check the progress there. For some reason, that's not spinning up. Let's check the node driver events. CNI is forbidden. No, I put that in the wrong scope. You'd want to do this as a system level component, primarily because it's going to do CNI level changes to your cluster. I can make the browser screen a little bit bigger. Let's go to Apps, Launch, back to Istio CNI. Choose a namespace. Let's put this in Istio system. Make sure we're on the right cluster. And then we are going to, I think that's sufficient. Now we'll go through. We might get the same permissions required. I'll have to change the permissions to install the CNI. The easier way would probably just be to use the Istio operator configuration. Let's go to latest, docs, setup, more guides, install Istio with a CNI plugin. Basically, this is the cat step that I mentioned previously, and I should make that a lot bigger. That's pretty small. You can see it's using the kind Istio operator. You're specifying that CNI is enabled. You're specifying the include namespaces, Istio system, kube system, and then you're specifying the log level. And then it's just the Istio install command. Cool. So that brings us to the point where I should start talking about the different gateways. I'm going to go back into presentation mode. I'm going to briefly talk about the components, and then we'll go back into the cluster and see them. So the first one is Ambassador, again, alphabetically sorted. It is running on Envoy. This is the slide or the card from the CNCF interactive landscape. You can see the website, gameambassador.io. Ambassador Labs used to be called DataWire. So when you're searching through GitHub, make sure you use DataWire/Ambassador. It's open source. And then you can see that they're a pretty small company, but they've been around for a fair bit of time. A couple of notes on the installation of Ambassador. I installed it with Istio 1.5.10 on EKS 1.17. I deployed strictly using Kubernetes resources, primarily because the Istio integration with MTLS, their documentation just has a deployment that you replace. And it made more sense for me to do that with vanilla Kubernetes resources as opposed to a Helm chart. Additional steps required to do the MTLS is they have a CRD for a TLS context, which allows you to specify where the secrets are coming from, and then a mapping, which is more or less an abstraction, a more sophisticated way of doing ingress. One thing that I will mention about their documentation is that they do go forward and talk about various other integrations with the service mesh. They show you how to integrate Jaeger. They show you how to integrate Prometheus and Grafana, and I think they also show you how to. There's one more facet I can't remember at this point in time, but they are having some issues with the. Okay, they're having some issues with the secrets switch from general secret store in a cluster to SDS. Gloo is the second. I have a question. Why is there a dependency for Ambassador API Gateway on Istio Service Mesh, and what are those? There is no dependency. You can run either independently. I just recommend that you run both because they have different functions. Gloo is another API gateway. Gloo is basically strictly written in Go. It's made by the folks at solo.io, github.com/solo.io/gloo. It's also based on Envoy. They've been around for 3 years, it says. They're also in the middling range of headcount. You can see 11 to 50, and they've got pretty current engineering talent, engineering commits and pushes. Gloo notes, I was able to install Gloo on Istio 1.6.6 on GKE 1.15.12. I deployed it using GlueCTL. I've more and more as Kubernetes evolves and architectures become consistent and tool sets become more abstracted, you'll find that there are more CTL commands. There's GlueCTL, there's Istio CTL, there's kubeflow CTL, et cetera, et cetera. The GlueCTL command was pretty straightforward for me, so that's why I used it. Their CRDs that make the network adjustments or the traffic routing possible are something called an upstream and a route. One thing that I will point out about their installation instructions is that I was very happy that they included the specific versions of Istio and the specific versions of Kubernetes and the cloud provider that they're running on when they tested their documentation against. If you're not aware, Istio also does a fair bit of QA testing against all of their documentation, which is, I think, should be the standard moving forward for any Kubernetes product. They do also, one last note here, is that they have the ability to do a read-only UI with the GlueCTL command. I think, yeah, all three of these products have the ability to integrate with the UI, but in many cases, the UI is wrapped up in an enterprise product that requires a license. Last API gateway that I'll be leveraging is Kong. Kong has been around for 6 years. It's a much larger company. Their company is actually Kong HQ, but everything on GitHub is under Kong. You'll notice that they have a couple other products, and the majority of their language is based in Lua. Kong notes, I was able to install Kong on Istio 172 with GKA 117.9. I deployed this using Kubernetes resources. I honestly just went to the Istio blog, and there's a how do we integrate Istio and Kong section, and I just followed that. That was really straightforward and really easy. This requires an ingress, a Kong ingress, and a service annotation to get stood up properly so that it's integrating with the Istio platform. And then to go back to the point where this just worked when I went through the installation instructions, either I just got lucky or it's not very finicky. I should probably do some further testing to prove that out. And then one last thing I want to mention is that the default for the Kong installation is to run without a database, and so it's storing everything in memory. That's the method that I'll be using, but they do give you the ability in the chart to install a Postgres database or directly, or to point to an external data store. Cool. So that brings us to the demo function, the demo section. I've got about 10 or so minutes to communicate or to show you the concepts of each of the clusters. So if we look at this Rancher environment, I have the various cluster environment, the various components. Each of them has its own cluster. If we start with EKS Ambassador, and we look at the default project, if we look at the workloads, after deploying Ambassador, there is an Ambassador service. That Ambassador service sends its information out through Redis as the cache. And it also, in order to integrate it with Istio's MTLS, there's a sidecar proxy that's running on the same version of Istio's sidecar as your service mesh would be. You'll see that in each of these clusters, I have in the default namespace the Istio demo. That Istio demo is just the standard fare. Product page goes to details and ratings, and then or details and reviews, then one of those review servers goes to ratings. As far as functionality, well, let me go into the node driver cluster that also has Ambassador. If we look at that default space, you can see the same things. If we look at the load balancing tab, we can see that I have Ambassador set up to communicate as an ingress controller. So there's a load balancer behind it because this one's running in EK or Amazon. If we go here and we look at product page, we can see the product page, the various incarnations of the product page based on the review service. And then if I look at, let's close these two windows. If I look at the Istio tab on this cluster, the traffic graph, you can see, let's open up Kali itself. Graph. I'm gonna have to make that slightly smaller. That's going to take that and run just a load generator. A, Q, 10, Z, and minutes. That will send requests to the service. And there we go. We can see through Kiali, ideally in real time, refresh it every little bit, that we're getting, let's go to Edge, let's display security. We can see right now, I have it set up so that MTLS is within the cluster. I don't have it with this boundary. We'll see that functionality within the Kong more specifically. But you can also see that the traffic is flowing freely to that display traffic animation. You see the traffic is flowing from the Kong API gateway to the various service mesh components. Or sorry, not Kong, Ambassador in this case. That's what this unknown element is. Moving on to the Kong environment, because the Kong environment has a noticeable difference. We go into the default project. We see the workloads tab. If we go to workloads, I also have Ambassador in that one, but that's just a remnant of some of my tests. Kong, since it's running without the database enabled, is just running the one ingress agent. That ingress pod is running Istio init because Istio is enabled on this namespace. It's running the proxy. And then there's the ingress controller, and then there's the Istio proxy. So there's a second proxy, I guess, which is performing some of the tasks that are required to make sure it's handing off between Kong and the service mesh. If we look at, so this one's slightly different because of the way that I installed Istio, but let me get the Kong components. If we look at load balancing, we see this Kong proxy, view edit YAML, get the IP address. We can look there, product page. Cool, that's still running from last night. You can see that behaves as normal. But what we will also see is, I'm going to close that for now, is that if we go into the cluster itself and we launch kubectl, we get peer authentication, strict MTLS. We'll see that right now it's connected to the MTLS. So it's going into Kong and it's communicating with all the downstream services with strict mode. Anytime, if I were to try to communicate using the other ingress controllers that are provided in this cluster, they'd get rejected. And I can show an example of that here. Load balancing. There's an ambassador load balancer. Let's view edit YAML, get the IP address of that ingress. You can see that one's, that's that more or less the error that happens when you can't negotiate TLS. And just to prove that out, let's go back one step. We'll go into the cluster, we'll launch kubectl, okay, edit peer authentication. Let's replace strict with permissive. Save that. It's been edited. We should start seeing traffic flow there. There we go. So once I disabled the requirement that everything's MTLS, we have access to the environment again. Similarly, and last but not least, I have GKE with Gloo set up. This environment has the default demo project. Gloo is distributed across 4 different services. Those services are discovery service, gateway service, the gateway proxy, and then Gloo itself. If I were to enable the read-only UI, there'd be the Gloo API there as well. You can see that there is a Gloo system load balancer. And then once again, if we look at this, view edit YAML, look here, copy that. We can see that there. The service is behaving as normal. And then I don't remember the state I left this cluster in. Let's double check what the MTLS requirements are. kubectl get peer authentication. There's no peer authentication on this guy. So that's not enforcing MTLS. But I went through the process and I installed it on the cluster. So if we looked at this guy, this gateway proxy, we would see that it also has an SDS pod and an Istio proxy, so that it can negotiate, so that it can pull certificates as required and get them and communicate with the service mesh. All right, so that was a very brief demonstration of the various components there. I have 8 minutes left. I probably should have timed this out a little bit better. But I'm going to start looking at the questions. I know there's a bunch of questions. The last question that I see are, what are the pros and cons of API gateways that run outside of the Kubernetes cluster as compared to the ones you've talked about here? For example, Amazon's managed API gateway service or something self-hosted running outside of Kubernetes. The main reason that I went with the API gateways as installed on a Kubernetes cluster is that I'm trying, again, to consolidate the control plane interaction so that I don't have to go between AWS console and Kubernetes. That becomes a little bit less of a strict scenario because I know that you can interact with AWS resources from Kubernetes these days. I know that you could probably do the reverse and interact with everything outside of Kubernetes. But for the most part, Rancher is my main pane of control. And so that's the reason I did that there. As far as cons go, if you're running, let's say, the Amazon's managed API gateway, you just have to be aware that if you're communicating with GKE or Azure, there might be added latency. You might be doing unnecessary hops or something like that. It's really just a matter of where it's put and whether or not it has access to all of your environments. In terms of resource consumption, what's the best solution? Ambassador seems better. I didn't actually do a resource consumption, but I can check that. If we look at Ambassador and we look at, I didn't enable monitoring, so I take that back. We wouldn't be able to see the standard usage over the last couple of hours. What is the main advantage of using an Envoy-based API gateway compared to a traditional API gateway like Freescale? The main reason I used Envoy was because the service mesh that I'm using is based on Envoy, and that really facilitates the handoff from the API gateway to the service mesh. I have a comment in my presentation, which I should probably go back to for the remaining time, about the fact that I kind of avoided the question of or why I focused on Envoy and not having and trying to be agnostic, but just because I chose Istio as my service mesh. There is one more question that I will answer, but I want to get through the slide deck. So in summary, I do mention that there are other meshes and gateways that don't leverage Envoy, so I'm not a liar. Traffic and Mesh by Contentious, Console by HashiCorp. Kong also has Kuma as their service mesh. Linkerd by Linkerd, or by Buoyant. As far as other products in the suites of the companies that I talked about already, Kuma and Insomnia both come from Kong HQ. Insomnia being an API developer portal, or being an API framework or essentially a UI to interact with like Swagger docs or open API specs at this point. They also have an enterprise version that allows you more of a UI-driven approach. As far as, well, all of the services have their own developer portal. Telepresence also comes from Ambassador Labs, as well as their Ambassador developer portal. And then Solo.io has a bunch of products. Some of them listed here are Service Mesh Hub, their Istio developer portal, along with Autopilot and I think Squash and stuff like that. The thing that's consistent about all of the tools that I use is that they're open source. I wouldn't tend to use a non-open source project if an open source project does exist, just because community support is quite helpful these days. So with that being said, there's ways to contact me, but I'd like to use the remaining time to discuss some of the remaining questions. We have 4 minutes left. That's the main advantage. Any issues running these in an on-premise K8s cluster rather than on public clouds? I did run them on public clouds, depending on the distribution of Kubernetes that you're leveraging. This was just the easiest path to entry. This is the way that I can I believe, and this is my assumption, the companies that were creating Ambassador, Gloo, and Kong test against at least EKS, maybe GKE. You're less likely that they've tested against a proprietary on-premise solution, but as long as Istio is compatible with specific components, then on-premise shouldn't add any additional overhead or complication. You just have to choose either your load balancing option or whether or not you're using node ports. I don't think I have enough time to go over more advanced Helm usage. That could be, I know there are Helm masterclasses out there if you look through the Rancher channel. Another on-premise question. I do want to correct one of the comments here. If I'm following right, the difference between Ambassador, Gloo, and Kong API gateways is ingress proxy without using cloud-specific load balancers. The main difference is the implementation of what happens after, or of their ingress controller itself, and then what happens with the traffic after that. If you look at each of the specific components, I would suggest getting familiar with the way that they've created CRDs. CRDs and the annotations on the various components. That's going to give you a good architectural overview of the way that they've designed the product. Running on premise with strengths and weaknesses. Linkerd, I did not say is 100% based on Envoy. Kuma is based on Envoy, so is Open Service Mesh. Thanks for that clarification. I haven't run Open Service Mesh or Kuma myself. When I get time, I probably will. And it's 100% open source. I see the traffic, is that available? So the UI that I used to see the traffic was Kiali. Kiali comes in various states in the various Istio installations I had. In the first Istio installation I showed, it was part of the Rancher integration. And the other two, I exposed it through the Istio CTL dashboard, which is essentially port forwarding the service from my local on my local host. But Kiali is pretty useful as far as interacting or showing visibility of the traffic on your Istio service mesh. Okay, so that brings us to 3 o'clock Eastern Standard Time. I just wrap up saying, let's go back to the presentation. Thanks everybody for your time. I know I didn't go over the API gateway functionalities. I left the door open for either Ambassador or Kong or Gloo to do other presentations, maybe on top of Rancher, or I'm sure if you go to their respective YouTube channels, you'll be able to find the inner workings of each of their service meshes, how an upstream works, how a mapping works, et cetera, et cetera. I am by no means an expert on any of them. I'm just a user of their basic ingress functionality as it relates to a service mesh, and I want to know how they interact with the various service mesh components. If you want to contact me for if you want me to do something like that, where I go into maybe the metrics, the MTLS ease of use, maybe some of the inner workings of how they're structuring their Helm charts, reach out to me on slack.rancher.io. I'm at Shipwreck. But I think with that said, that's all I got.
Great. Thank you so much, Jason. This was a great topic, lots of great questions. And thank you again to everybody who was able to attend today. If you haven't yet, head over to rancher.com to check out Rancher and all of our other products and projects here. Everything's open source. And if you are interested, we do have a couple more resources here that are available for you. You can get certified as a certified rancher operator. Head to academy.rancher.com to find out more. And we do also have an upcoming conference covering all things Kubernetes on the edge. If you have any great topic ideas, you can head over there to submit a call for presentations and also to register for the free conference. Last but not least, our next Kubernetes masterclass will be next Tuesday, September 29th. And I think is a great follow-up here to cover observability, and it will feature our partner Datadog. So head to rancher.com/events to sign up for that class. And otherwise, thank you again. Thank you, Jason, for taking the time today, and for everybody who was able to attend. Have a great rest of your day.
All right, take care, everybody.